Students, welcome to Excel Tuition, and today we'll solve mathematics paper for English medium term 1 for standard 9th. Maximum marks 80. This is a set C. Total questions 43. Instructions. First, this question paper consists of 43 questions. All questions are compulsory. This question paper is divided into 4 sections A, B, C and D. In section A, question number 1 to 20 are multiple choice questions, MCQs, and question number 9 and 10 are assertions or reason based questions of 1 mark each. In section B, question numbers 21 to 31 are short and answer type 1, SA1 questions carrying 2 marks each. In section C, question numbers 32 to 41 are short answers type 2, that is SA2 questions carrying 3 marks each. In section D, question number 42 and 43 are long answer LA question carrying 4 marks each. There is no overall choice. However, an internal choice has been provided in 2 questions of 2 marks each in section B and 2 questions of 3 marks each in section C. In questions on construction, the drawing should be clear and exactly as per given measurements. The construction lines and arcs should also be maintained. Use of calculator is not permitted. This is a term 1 question paper for standard 9. You will get 3 hours to solve this question paper. This is October 2025 question paper. So let us start solving this paper. Section A. Each question has 1 mark each. Select and write correct alternatives from those given below each statement for questions 1 to 20. These are MCQs. First, the relation between sin theta, cos theta and tan theta, where theta is not equal to 90 degree is. The options are sin theta plus cos theta is equal to tan theta, sin theta minus cos theta is equal to tan theta, sin theta into cos theta is equal to tan theta, and sin theta divided by cos theta equal to tan theta, and the correct option is fourth, sin theta divided by cos theta is equal to tan theta. Question number 2. If 6 raised to x plus 1 is equal to 36, then the value of 3 raised to 2x plus 1 is dash. After solving this, we are getting the answer 27. The options are 1, 9, 3 and 27, and the correct option is 27, which we get after solving this sum. Question number 3. If 25x square minus b is equal to 5x plus 1 upon 7, 5x minus 1 upon 7, then the value of b is, here the equation is 25x square minus b is equal to 5x plus 1 upon 7, 5x minus 1 upon 7. We have to find the value of b. So after solving this, a plus b into a minus b is a square minus b square. So a we have taken 5x and b is 1 upon 7. So equal to 5x square minus 1 upon 7x square. So 25x square minus b is equal to 5 5 is 25, x square is x square, 1 square is 1 and 7 square is 49. So after solving this, we are getting the answer b is equal to 1 upon 49. So the options are 0, 1 upon 49, 1 upon 7 and 1 upon root 7, and the correct option is 1 upon 49. Question number 4. If line Rn intersect line PM at O, line Rn intersect PM at O, then the value of x, we have to find out the value of x here. Options are 30 degree, 60 degree, 40 degree and 120 degree. Here these two angles are vertically opposite angle. Therefore 3x is equal to 120 degree. But we have to find out the x. 3x is equal to 120 degree. Since it is vertically opposite angle, 3x is equal to 120 degree. X is equal to 120 upon 3. So 3 ones are 3 and after cancellation we are getting here 40. So x value of x is 40 degree. So the correct option here is 40 degree. Question number 5. In triangle PQR, side QR is produced to S. If angle PQR is equal to 40 degree and angle PRS is 120 degree, then the measure of angle P is dash. Options are 40 degree, 60 degree, 50 degree and 80 degree. By using the exterior angle theorem, exterior angle is equal to sum of the two opposite angles. So 120 minus 40 is 80 degrees. So correct option is 80 degree. Question number 6. Two angles of a quadrilateral are 40 degree and 90 degree and the other two angles are in the ratio 8 is to 15. Then these two angles are, options are 70 degree, 160 degree, 90 degree, 140 degree, 80 degree, 150 degree, 100 degree, 130 degree. We can solve this as, draw figure first, 15x, 8x and this is 40 degree, this is 90 degree. So sum of the angles of the quadrilateral is 360 degree. So adding all four angles, here we are getting 130 plus 23x is equal to 360 degree. So 23x is equal to 360 minus 130, that is 230. So x is equal to 230 upon 23, that is 10 degree. This is the value of x. So 8x is equal to 8 into 10, 80 degree and 15x is equal to 15 into 10, 150 degree. So these are the two measurements of the angle. So the correct option is 80 degree and 150 degree. Question number 7. If angle A is equal to 30 degree, the value of 2 sin A cos A is dash. Here we have to substitute the known values. And the options are 1, 1 upon root 2, 1 upon 2 and root 3 upon 2. Angle A is 30 degree, 2 sin 30 into cos 30 degree. So 2 into sin 30 value is 1 upon 2 and cos 30 is root 3 upon 2. 2 will get cancelled. 1 into root 3 upon 2 is root 3 upon 2. So the correct option is root 3 upon 2. Question number 8. The value of sin 51 degree minus cos 39 degree is dash. Options are minus 1, 1, 0 and 2. We will solve this as cos 39 is equal to cos 90 minus 51 degree. So sin 51 degree. So sin 51 degree minus cos 39 degree. So sin 51 minus sin 51 is 0 degree. So the correct option is 0. Directions. In question number 9 and 10, a statement of assertion A is followed by a statement of reason R. Select the correct option from the following. Both assertion A and reason R are true. Reason R explains assertion A completely. Both assertion A and reason R are true. Reason R does not explain assertion A. Assertion A is true but reason R is false. Assertion A is false but reason R is true. Question number 9. Assertion is the expression 1 upon x plus 3 is a polynomial. Reason is a polynomial is an expression where the exponents of the variable must be a whole number. So here the correct option is both. Assertion A and reason R are true. Reason R explains assertion A completely. Question number 10. Assertion A. In triangle KLM and triangle PQR, angle K is equal to P, angle M is equal to R, and KM is equal to PR. Then triangle KLM is congruent to triangle PQR by ASA congruence rule. Reason: if two angles and the individual side of one triangle are equal to the two angles and the included side of the other triangle, then the two triangles are congruent. So here both assertion A and reason R are true. Reason R explains assertion A completely. Question number 11. Every rational number is. Options are a natural number, a whole number, an integer, and a real number. And the correct option is a real number. Which of the following is irrational? Options are 0.13, 0.1315 bar, 0.01315, 0.1301300, and the correct option is 0.1301300. Question number 13. The degree of the quadratic polynomial is. Options are 0, 2, 1 and 4, and the correct option is 2. Question number 14. If x is equal to minus 2 is a 0 of the polynomial 3x square minus x plus p, then the value of p is. Options are minus 8, 10, minus 14 and plus 14. Since x is equal to minus 2, we can solve this as 3x square minus x plus p is equal to 0. So minus 2 is substituted in this equation, and here we are getting the answer p is equal to minus 14. So the correct option is p is equal to minus 14. Question number 15. How many lines can be drawn through two distinct points? Options are none, at least two, exactly one, and infinitely many. And the correct option is exactly one. Question number 16. One angle is equal to 4 times its supplements. Then the measure of the greater angle is. Options are 36 degree, 144 degree, 135 degree and 180 degree. So x is equal to 4 into bracket 180 minus x. So 4 into 180 is 720. 4 into x is 4x. So x plus 4x is equal to 720. 5x is equal to 720. So x is equal to 720 upon 5 is equal to 144. So here the correct option is 144 degrees. Question number 17. The sum of an angle and its corresponding reflex angle is. Options are 90 degree, 270 degree, 180 degree and 360 degree. And the correct option is 360 degrees. Question number 18. In triangle STQ, ST is equal to SQ and angle T is equal to 70 degree. Then the measure of angle S is. Options are 40 degree, 80 degree, 70 degree, 110 degree. Here we can draw a rough figure and we can solve the sum. So STQ is a triangle. These two sides are equal. This is a 70 degree. So this is an isosceles triangle. So angle S plus 70 plus 70, that is angle Q plus angle T is equal to 180 degree. So angle S plus 40 degree is 180 degree. So angle S is equal to 180 minus 140 is 40 degree. Here the correct option is 40 degree. Question number 19. 4 points PQ RS are joined together in order such that PQ is equal to RS and also PQ is parallel to RS. Then the quadrilateral obtained is always a kite, rhombus, rectangle and parallelogram. And the correct option is parallelogram. Question number 20. If sine theta is equal to root 3 upon 2, then theta is. Here the value is given and you have to find out the angle. So options are 30 degree, 60 degree, 45 degree and 90 degree, and the correct option is 60 degree. Now we'll move to section B of the question paper. Section B, 2 marks for each question. Question number 21. Represent the number root 3.7 on the number line. Here we have to construct a number line showing root 3.7. Let us construct the number line showing root 3.7. Question number 21. Draw a line, then mark 3.7 as AB, then mark as 1, 2, 3, 4, 5, 6. Then bisect AC. Draw a line through these points. Now draw a semicircle C to A. Draw a semicircle from C to A. Construct 90 degree from point B. Join the line with the help of compass. Now draw an arc. BD. Now joint OD. Construct an arc, and this is your root 3.7 representation of root 3.7. Question number 22. Express 0.24 bar in the form of P upon Q, where P and Q are integers and Q is not equal to 0. So after solving here, we are getting the answer is, let x is equal to 0.24. So 100x is equal to 24.24. So subtract 1 from 2. After subtracting, we are getting a 99x is equal to 24. So after cancellation, here we are getting the answer x is equal to 8 upon 33. Question number 23. Factorize by splitting the middle term. Here I have solved both the expressions. You have to solve only one. So 2x square minus 7x minus 15, or 4x square plus 12x minus 7. You can solve any one of these. So first we have to find out the factors of 15 to the 30. So these are the factors of 30. Now 2x square minus 10x plus 3x minus 15. So take out the common from these two and these two. So 2x is a common. Into bracket we are getting x minus 5. So write this x minus 5 only one time, and 2x plus 3 is one factor and x minus 5 is the other factor. 2x is equal to minus 3. So x is equal to minus 3 upon 2 and x is equal to 5. Second one is 4x square plus 12x minus 7. So 4x square minus 2x plus 14x is minus 7. Factors of 28 by using prime factorization method. And here we are getting the factors 2x plus 7 and 2x minus 7. Question number 24. Simplify. 81 raised to 1 upon 2 into 64 raised to 1 upon 3 plus 125 raised to 1 upon 3. Let us solve this. We will find a number so that we will get a base 2, 3 and 5. So here 81 can be written as 3 raised to 4, 64 is 2 raised to 6, 125 is 5 raised to 3. So using the laws of exponents, here we are getting 2 1s are 2, 2 to the 4, so here 3 square, here also 2 3s are 6, so here both the 3's are getting cancelled. So after solving this, we are getting the answer 117. Question number 25. Using the factor theorem, determine whether x minus 1 is the factor of 2x cube minus 3x square plus 6x minus 5. So 2x cube minus 3x square plus 6x minus 5. And here x minus 1 is equal to 0, therefore x is equal to 1. Substituting this x is equal to 1 in the equation, and after solving here we are getting 0. Therefore x minus 1 is the factor of 2x cube minus 3x square plus 6x minus 5. Question number 26. In the following figure, line P is parallel to line Q and line T intersect line P and line Q. Then find the value of x and y. Here the figure is given, here x and y, and here 5x. We have to find out the values of x and y. We have marked this as A and this as B. So angle A is equal to angle X, as these two are parallel to each other, and this is a transversal. Angle A is equal to angle X because they are corresponding angles. So x plus 5x is equal to 180 degree. So this is x, so A is also x. So x plus 5x is 180 degree. So x is equal to 30 degree. And B is equal to 5x. That is also a corresponding angle. Angle Y is equal to angle B. So 5 into 30 degree. Therefore it is 5x is 150 degree. Therefore y is equal to also 150. Question number 27. Expand using suitable identity. 3x minus y plus 2z square. 3x minus y plus 2z square. After using the identity a square plus b square plus c square plus 2ab plus 2bc plus 2ca and substituting this a, b and c in this identity and solving, we are getting here 9x square plus y square plus 4z square minus 6xy minus 4yz plus 12xz. Evaluate using a suitable identity. Either you can solve this or this. So 102 cube. Using this identity, a plus b cube is equal to a cube plus b cube plus 3a square b plus 3ab square, and splitting 102 as 100 plus 2 cube. Substitute this as 100 as a and 2 as a b in this identity, and after solving this, here we are getting the answer 1061208 is the answer. Question number 28. If a point T lies between 2 points P and Q such that PT is equal to QT, then prove that PT is half of PQ. We can solve this as PT is equal to QT, which is given. Then total length is PQ. That is PT plus TQ is PQ. And since PT is equal to QT, substituting PT for TQ in equation 1. So PQ is equal to PT plus TQ. Means PT plus PT is 2PT. Here it is multiplying, so when it comes to left hand side it will divide. So PT is equal to PQ upon 2, or we can write as a PT is equal to half of PQ. Question number 29. WXYZ is a parallelogram and WP and YQ are the perpendiculars from the vertices W and Y on the diagonal XZ. Prove that WPX is congruent to YQZ. To prove this, there are more than one methods. I am showing you this one method. So given WXYZ is a parallelogram, WP is perpendicular to XZ and YQ is perpendicular to XZ. So we have written here whatever is given in the problem. So wx is parallel to zy. Opposite sides of parallelogram are parallel. Angle WXP is equal to angle YZQ. Alternate interior angle or WXZ is equal to angle YZX. So WX is equal to ZY. Opposite sides of the parallelogram are equal. WP is perpendicular to XZ and YQ is perpendicular to XZ. This also is given. Angle WPX is equal to 90 degree. Angle YQZ is also 90 degree. So perpendicular lines. So therefore they are right angles. So angle WPX is equal to angle YQZ. Both are 90 degree. Triangle WPX is congruent to triangle YQZ by AAS congruence rule. Since angle WXP is equal to angle YZQ, angle WPX is equal to angle YQZ and WX is equal to ZY other side. So AAS, hence proved. Question number 30. Evaluate the following trigonometric expression using known numerical values of trigonometric ratios. 3 tan square 30 degree plus 8 sin square 45 degree. Value of tan 30 is 1 upon root 3 and sin 45 degree is equal to 1 upon root 2. So 3 tan square 30 degree plus 8 sin square 45 degree is 3 into 1 upon root 3 square plus 8 into 1 upon root 2 square. So after solving here we are getting the answer 5. In the following figure, line AB is drawn parallel to QR through vertex P and triangle PQR. Show that angle 1 plus angle 2 plus angle 3 is equal to 180 degree. Angle 1 plus angle 2 plus angle 3 is 180 degree that we have to prove. Angle 1 plus angle 2 plus angle 3 is equal to 180 degree. We have to prove this. Since line AB is parallel to line QR and line PQ is transversal, angle 4 is equal to angle 1 and alternate interior angle. Angle 1 and angle 4 is alternate interior angle. Similarly, since line AB is parallel to QR, line PR is a transversal. So angle phi is equal to angle 2. Angle phi and angle 2. Alternate interior angle. Angle 4, angle 3 and angle phi lies on a straight line at a vertex P. So this you can write as angle phi equal to angle 2 alternate interior angle, angle 4, angle 3, angle phi a straight line at vertex P. Angle 4 plus angle 3 plus angle phi is equal to 180 degree. Sum of the angles of the triangle is 180 degree. Substitute angle phi is equal to angle 2 and angle 4 is equal to angle 1. So angle 1 plus angle 3 plus angle 2 is 180 degree. So we can rearrange it as angle 1 plus angle 2 plus angle 3 is 180 degree. Hence, now we'll start solving section C, 3 marks each. Question number 32. If A and B are two rational number and root 5 plus root 3 upon root 5 minus root 3 is equal to A plus B root 3, then find the values of A and B. As I told you earlier, there are more than one methods to solve such sums. I am showing you one method. A plus B root 3 is equal to this. Now we will rationalize this first. So root 5 plus root 3 upon root 5 minus root 3 into this minus will become plus here. So root 5 plus root 3 upon root 5 plus root 3. root 5 plus root 3 into root 5 plus root 3 is root 5 plus root 3 square. After expanding, here we are getting root 5 square plus 2 into root 5 into root 3 plus root 3 square upon this a minus b into a plus b is a square minus b square. So root 5 square minus root 3 square. Here root and square will get cancel, root and square. So pi minus 3 is 2. So after solving here we are getting 8 plus 2 root 15 upon 2. So equating rational and irrational parts, we get a is equal to 4, b is equal to 1. So the expression is 4 plus 1 root 15. So the values of a is 4 and b is 1. Question number 33. Divide the polynomial 2x raised to 4 minus 3x cube minus 3x square plus 6x minus 11 by the polynomial x square minus 2 and write the quotient and remainder. This I have solved here by using long division method, and here I am getting the quotient as 2x square minus 3x plus 1 and the remainder is minus 9. Question number 34. In the following figure, AB is parallel to CD and EF is parallel to DQ. Angle PDC is equal to 32 degree and angle FEB is equal to 66 degree. Find the measure of angle AED and angle DEF. This angle, this, and PDQ. You have to find PDQ also. First we will solve AED. Angle AED is equal to CDP. Since they are corresponding angle, therefore AED is equal to 32 degree. Angle DEF is equal to, we have to find out. So AED plus DEF plus FEB is equal to 180 degree. Angles on the straight line or the linear pair. So 32 degree plus angle DEF plus 66 degree is 180 degree. So after solving here we are getting angle DEF as 82 degree. Next we have to find out angle PDQ. Angle PDQ is equal to angle DEF. Since DQ parallel to EF and these two are corresponding angle, therefore angle PDQ is 82 degree. In the following figure, AC is parallel to D and D is parallel to B. Also angle PAC is equal to 70 degree and DAC is 45 degree. Find the measure of angle ACB, angle FBC and angle FAD. Here this 70 degree, 45 degree is given. These two are corresponding angles since AD and B are parallel and AC and D also parallel. So we can say as angle ACB is equal to DEC is equal to 45 degree since they are corresponding angle. FBC plus angle BAC plus angle ACB is equal to 180 degree. By using angle sum property of a triangle, sum of all the three angles of a triangle is 180 degree. So after solving we are getting here FPC is equal to 65 degree. Next is angle FAD is equal to FBC or ABC, that is corresponding angle. So FAD is equal to ABC equal to 65 degree because corresponding angles are same measurement. Question number 35 and 36 is most repeated question and my video will be coming now too lengthy. So these sums you will get on your textbook. Question number 37. ABC is an isosceles triangle in which AB is equal to AC. D and E are the midpoints of AB and AC respectively. If D is equal to 4.5, D is equal to 4.5 and AD is 6.5, then find the perimeter of ABC. So we have to find out the perimeter of ABC. Triangle ABC. So perimeter of triangle ABC is AD plus DB plus BC plus CE plus EA. AD is given 6.5, DB is also 6.5, BC is not given. C is 6.5 and EA is also 6.5. So to find BC, given D is equal to 4.5 and D is half of BC, that is using midpoint theorem. So D is 4.5 is equal to half of BC. So BC is equal to 4.5 into 2 is 9 centimeter. Now substitute this. BC is equal to 9 in the above equation. Here BC is equal to 9. We have substituted a 13 plus 13, 26 plus 9 is 35 centimeter. So the perimeter of triangle ABC is 35 centimeter. Question number 38. In triangle MAT, angle A is equal to 90 degree, AT is equal to 24 centimeter and MT is equal to 25 centimeter. Find the value of MA, cos M and tan T. Here the figure is given MAT and this is a right angle. And side opposite to the right angle is hypotenuse. MA square plus AT square is equal to MT square by using Pythagorean theorem. So substituting the values here, we are getting MA square is equal to 49. So MA is equal to root of 49, that is 7 centimeter. So the third side MA is 7 centimeter. We have to find the cos M. Cos M is equal to MA upon MT. That is adjacent upon hypotenuse, that is 7 upon 25, and tan T is opposite upon adjacent, that is MA upon AT, that is 7 upon 24. Question number 39. Triangle ABC is a right angle at A. AL is drawn perpendicular to BC. Prove that BAL is equal to angle ACB. BAL is equal to angle ACB. Prove that angle BL is equal to angle ACB. Using angle sum property of a triangle, in triangle ABC, BAC is 90 degree, which is given. Sum of the angle of a triangle is 180 degree. Therefore, angle B, angle A and angle C is 180 degree. So substituting the values here, we are getting angle ACB is equal to 90 minus angle B. Angle ACB is equal to 90 minus angle B. Then in triangle ABL, AL is perpendicular to BC. Therefore, angle ALB is 90. Angle ALB is also 90 degree. Sum of the triangle ABL is 180 degree. Angle ABL plus angle BLA plus angle BAL is 180 degree. Substituting the values, angle B plus 90 degree plus angle BAL is equal to 180 degree. Therefore, angle BAL is equal to 90 minus B. From equation 1 and equation 2, here we are getting angle ACB and angle BAL are equal, since 90 degree minus angle B is equal to 90 degree minus angle B are the values of these angles. Therefore, angle BAL is equal to angle ACB, hence proved. In the following figure, AB is perpendicular to BD and CD is perpendicular to BD. If AQ is equal to CP, AQ is equal to CP and BP is equal to DQ. BP is equal to DQ respectively. Prove that triangle ABQ is congruent to triangle CDP. Since AB is perpendicular to BD and CD is perpendicular to BD, therefore angle ABQ is equal to 90 degree and CDP is also 90 degree. Both are right angle triangle. So AQ is equal to CP, hypotenuse are equal, which is given, and BP is equal to DQ is also given. By congruence rule, in right angle triangle, ABQ is equal to CDY. Hypotenuse AQ is equal to hypotenuse CP is given. Side BP is equal to side DQ is also given. By the right angle hypotenuse side RHS congruence rule, triangle ABQ is congruent to triangle CDP. In the following figure, ABCD is a trapezium in which side AB is parallel to DC. E and F are the midpoint of the side AD and BC respectively. Also, EF is parallel to DC. Show that EF is half of AB plus DC. I have drawn a rough figure. You use pencil and ruler to draw this. Now join BD intersecting EF at point G. E midpoint of AD is the midpoint of AD is given. EF is equal to DC. First you have to write whatever is given. Then AB is parallel to DC and EF is parallel to AB is parallel to DC. In triangle ABC, EG is a line segment drawn through the midpoint E of AD and is parallel to the base AB since EF is equal to AB. By converse midpoint theorem, G must be midpoint of BD. By midpoint theorem, length of EG is half of AB. EG is equal to half AB. Mark this as a equation 1. Applying midpoint theorem in triangle BCD also. G is the midpoint of BD. GF is joining G to BD and midpoint F of BC. By midpoint theorem, since line GF is parallel to base DC and its length is half of the length of DC, GF is equal to half of DC. Now mark this as a equation 2. From 1 and 2 and substituting, EF is equal to half AB plus half DC. In figure, EF is equal to EG plus GF, that is half AB plus half DC. So taking half as a common outside, so EF is equal to half into AB plus DC. Hence proof. Question number 42. Factorize the polynomial x cube minus 6a square plus 11x minus 6. You can use any method. Take out the factors first and then substitute. Here I have taken x is equal to 1. So substituting x is equal to 1 in the expression, here I am getting 0. Therefore x minus 1 is one of the factor of the given polynomial. I have done here long division taking x minus 1. Here I got the quotient x square minus 5x plus 6 and remainder is 0. So one of the factor is x minus 1. So this we have to find out the factors of this quotient. So first I have find out the factor of 6, that is 2 into 3, and using the splitting the middle term method, I have got the factor x minus 2 and x minus 3. So the factors, all three factors are x minus 1, x minus 2 and x minus 3. Students, if you like the content of our channel, kindly share, subscribe and like. So let us move to the last question. Question number 43. Given ABC is isosceles triangle, means two sides are equal, having AB is equal to AC, side BA is produced 2D such that AD is equal to AB. Prove that angle BCD is 90 degree. Angle BCD is 90 degree, that we have to prove. And triangle ABC is an isosceles triangle. AB is equal to AC and AD is equal to AB is also given. To prove that angle BCD is equal to 90 degree. In triangle ABC, since AB is equal to AC, let angle ACB is equal to ABC is X. We will consider this as X. Then in triangle ACD, since AD is equal to AC, because AD is equal to AB and AB is equal to AC. Then angle ADC is equal to angle ACD is equal to Y. Opposite angles of equal side are also equal. In triangle BCD, angle ABC plus BCD plus ADC is equal to 180 degree. So BCD is equal to ACB plus ACD. Substituting the values, x and y. So x plus y plus y 80 degree. After solving here we are getting 2 into x plus y is equal to 180 degree. Substitute angle BCD is equal to x plus y. Now 2 into angle BCD is equal to 180 degree. Divide both by 2. So after dividing here we are get 2 and 2 will get cancel, and 2 ones are 2, and here 90 to the 180 degree. So angle BCD is 90 degree, that is right angle. Therefore angle BCD is a right angle. Thanks for watching. Do share, subscribe and like for more such videos.